Here we go, starting lesson 2, function notation. This is of Algebra 1, Illustrative Mathematics, and this is starting on page 139 in your student workbook. 2.1 says back to the post. Here are the graphs of some situations you saw before. Each graph represents the distance of a dog from a post as a function of the time since the dog owner left to purchase something in a store. So this was the same as Unit 1, where that dog is tied with his leash and he's moving away. In one situation, he goes and sits down and stays, etc. So same scenarios from Unit for lesson 1. So on day 1, here's the little graph we made. On day 2, here's the graph on day 3. Using the given graphs to answer the following questions. How far away was the dog from the post 60 seconds after the owner left? So we go look at input of 60, follow it up. Dog was 4 feet from the post. Same thing, day 2, we go to the input of 60, follow it up. Dog was 4 feet from the post. And oh my gosh, 4 feet from the post. How'd you do on those? Did you get those on your own? Then second, part B, how far away was the dog from the post when the owner left? So again, we're going over here and looking at the beginning when the owner left, and we notice that they were the same distance, about 1.5 feet from the post, no matter what day it was. The owner returned 160 seconds after he left. How far away was the dog from the post at that time? So here we're going out to 160. So on the first one, what would you call that? I'm going to say like 3.7 feet away, whatever you think that is. On this one, notice that the dog sat down and just stayed in the same place. So just 4 feet from the post the whole time after that 60 seconds. And then on day 3, what would we call that? Like it's back, oh, not even 1.5. It's down at like 0.5 feet, like half a foot from the post. And then how many seconds passed before the dog reached the farthest point it could? What do you guys think the farthest point would be represented on this graph? You got it. It is that highest point of the graph on each one. And so on day 1, highest point, that happened at about 50 seconds. What do you think, in between 40 and 50? This one, the highest point, 34, 35 seconds. And then what about this one? Where did that highest point happen? Right away. That's where the dog goes and jerks on the leash and then like pulls back. So this is about 3 seconds after the owner leaves. This one we said was about 34 or 35 seconds. And this one we said was about, 50 seconds. And that's where, what is the time in seconds at that highest point? Those are called the outputs because they are the y-axis along the side. And these answers are the inputs. Reverse that. So when we're giving an answer of the time, that's here along the bottom, that's giving an answer of the input. And when we're giving an answer of the distance, that's the outputs along the side. Okay, consider the statement the dog was 2 feet away from the post after 80 seconds. Do you agree with this statement? Well, he was different point at all that time. So at 80 seconds here, at 80 seconds here, at 80 seconds here. So when asking this question, it depends on the day. Whether it's true or not. And then same thing, what was the distance of the dog from the post 100 seconds after? I can't say unless you tell me which day. So at this point, we realize that when there's a day 1, a day 2, and a day 3, it would be helpful to have a name for each of those functions so that I know which one I'm answering about. So this whole section is about why is function notation important for us to be able to refer to specific things in answering the questions. Here we go to 2.2, the handy notation. Let's name the functions that relate to the dog's distance from the post since the owner left. So I'm going to use 3 different colors here. Function F is going to be the name for day 1. Function G is going to be the name for day 2. And function H is going to be the name for day 3. So we're now giving them a name so we can refer to them specifically. So the distance from the post 60 seconds after the owner left, how would I put that into this specific name? And we're now going to use the name of the function F. So the function, let's go get the regular. Day 1 is called function F. And so we're going to say F of 60, our input. On day 2, we now call that function G. So we would call it G of 60. Say these out loud to yourself as you're doing them to practice this notation. And finally, day 3 at this input would be called H of 60. How about the distance from the post when the owner left? Well, the distance from the post when the owner left, the dog was literally standing at the post with the owner. That distance is 0. And so we're going to go F, first function's name, of 0. We're going to go G of 0, and we're going to have H of 0. So all of these equal 1.5 because the distance from the post when the owner left was 1.5 for all of these. But how do we call all these specific names? The new function names. Finally, the distance from the post 150 seconds after the owner left. Notice we're just taking each of those inputs and putting it in. Okay, repeat after me. F of 150, G of 150, H of 150. That's how we say these new function names. F of 150. So we throw a little word of in there. Have you heard of function notation before? Now let's go describe what these mean then using this new language that we're learning. So F of 15 is the distance from the post 15 seconds after the owner left. Actually, let me type with text so you can read it a little bit easier. Now, what do we specifically know by the name of F? It's on day 1. F is the name we're using for the day 1 function. Second one, try it. Let me pause for a second. You got it. It's the distance from the post 48 seconds after the owner left on day what? You got it. G stands for day 2. Finally, this one means the distance from the post T seconds after the owner left. You got it on day 3. So how'd you do? That's what this new function notation means in context with this scenario. On number 3, the equation G of 120 equals 4 can be interpreted to mean on day 2, 120 seconds after the dog owner left, the dog was 4 feet from the post. Pause the video and try to answer these next ones using the new function notation. All right, let's see how you did. So H of 40, what do you think? Equals 4.6. Well, H stands for the 3rd day. You got it. 40 seconds after the owner left, the dog, you got it, was 4.6 feet away. All right, pause the video, try the next one if you didn't get that one. What does F stand for again? Yeah, on the 1st day. The T seconds after the owner left, that's that input. The dog was 5 feet away. And then G stands for the second day. T seconds after the owner left. The dog was D feet away in distance. Okay, so again, we're just learning how to read this new notation that we're going to be using all chapter. The final one is just looking at what designates a function. One input has only one output versus not a function. Let's look at something like birthdays, non-math related, to kind of get this concept. Rule B takes a person's name as its input. So the left-hand side is going to be a person's name and gives their birthday as an output. And then rule P takes the date as the input and gives the person with that birthday as the output. So for example, it says Abraham Lincoln's birthday is February 12th, input output. August 26th is Katherine Johnson's birthday, input output. So let's go fill this in with some famous people's birthdays. I'm going to give you some examples, but you're totally welcome to go look some up on your own and complete your own table if you want to. But did you know that Alexander Hamilton's birthday is January 11th? Is this your birthday? Tell me if any of these famous people's birthdays is your birthday. Did you know that Frida Kahlo's birthday is July 6th? My birthday is July 5th, so I'm close. And then did you know that Rosa Parks' birthday is February 4th? So one input, one output. I only have one birthday. But going over here, if I reverse these, and let's say I put that March 14th is Albert Einstein's birthday. Well, aren't there other people with a March 14th? Couldn't I say March 14th is also my grandma's birthday? March 14th is my student's birthday. There could be multiple outputs for March 14th. Think of all the people born on that day. April 25th is Ella Fitzgerald's birthday. But couldn't there be multiple people with that same birthday? So in the questions below, they said complete each table with 3 more examples. You can totally use your own if you want. If you use your name as the input to be how many outputs are possible. So again, rule B is the one on the left here. If I put, actually, sorry, I'm still going to keep typing so it's better than my writing. Let me type the text box. If I use my own name, there is only one possible output. I only have one birthday. Darn it, I wish I had more. If you use your birthday as the input, there are many outputs possible, many people with the same birthday as me. Only one of the two relationships is a function. The other is not a function. Which one is which? Rule B, the first table, is a function because each person only has one birthday. Rule P is not a function because one birthday can have many people with that same birthday, many outputs. For the relationship that is a function, write 2 input-output pairs from the table using function notation. And so this might be different for you if you did different ones than me. But B of Abraham Lincoln equals February 12th. Or maybe you did your name. I'll do me. B of Karma Sanchez equals July 5th. There's only one output for my input. That's the first function. And then I'll do another one. I'll do Frida Kahlo. Something like that. That's you putting that function into function notation. One input has only one output is the definition of function. If you continue down, there's some extra work of Are You Ready for More if you'd like to complete it. And then as always, I'd like you to read through the summary and highlight important facts. If you're ever absent from class, besides watching these videos, going through and reading the summary or right before a test, reading through the summary can be very important and can help you. Go down to this page especially. The function notation we're going to be the most commonly using in this chapter is going to be the f of x notation, where f stands for the name of the function and x stands for the input. That entire title, f of x, is our output notation. F of x is the function notation for saying y. Y is our output in an XY table. F of x is the function notation for that output. So that's a good one to highlight there. Notice function notation is our one glossary word. How'd you do?